Okay. Hi, good afternoon, everybody. Thank you so much for joining us for this talk. My name is Florian Cole. I'm the manager of the Yale Quantum Institute and the host of this series of non-technical talk on science and the humanities that are co-sponsored by the Franklin Program in the Science and the Humanities. This series is trying to combat science phobia and quantum physics phobia too by introducing other medium to the field and talking about two different topics that has at the intersection of all of them. So in the past, you can see some of the slides behind me or on your screens. In the past, we had talks about quantum physics and music. We had physics and dance. We had mathematics and crochet. And today we are very excited to be joined by Stewart Smith to talk about the Hapless dreamers. And so in a very exciting talk about digital arts, augmented reality, and quantum simulators. So we started this series in 2017, and this is our 14th event of the series. So to give you a bit of introduction to Stewart Smith, so he's a digital artist and an AR technologist. He has worked at a very well-renowned hybrid studio like the Google Creative Lab and the Data Arts team. And founded Moar, technology and strategy consultancy. And is also currently the head of consumer augmented reality at Unity, the game engine. And so he received his MFA from Yale University in graphic design, and his artwork has been exhibited in the Museum of Modern Art in New York, at the ZKM in Germany, at the SFMOMA in San Francisco, and is part of the permanent collection at the Fondation Cartier in Paris. If all of that was not enough, on the side, he taught himself how to code, and he created and maintained the browser-based quantum circuit simulator, Q.js. So we'll talk a bit more about that. So I think that's something that's going to be very exciting for the quantum crowd. So the talk will last about 50 minutes, and then you will have time for questions. For the people on Zoom over there, there's a feature at the bottom of your screen called Q&A, so feel free to type your question in, and then we'll take them as they pop in. Please help me welcome Stewart Smith, and thank you for being here.
Thank you so much. Hi, as Florian said, I'm Stewart Smith. My background is in art, code, and graphic design. But I think it's also important to try to find the fun in making things. I do have a hard time describing what I mean by that. And so what I want to do is step through some more visual examples. And maybe those examples will promote some discussion, some arguments, some debate, and hopefully just describe what it is that I do. So, I'll give you a little overview of a few things, and then I'll go deep on about 4 projects. So here's a little overview. I've made music videos using vintage computers, which is a strange thing to do, but I'd say quite fun. Games that are played with Windows instead of within Windows. So a version of Pong for the browser that actually uses pop-up windows to play. Very large panoramic data animations that take up entire rooms. So you can walk into this animated data that's all around you. I've even crafted software synthesizers. This runs right in any web browser. It's open source. You can even plug in a MIDI keyboard right in your computer and you can play with it. And with any luck, let's just see if this. So there you go. You can try this out on your own time, and I'll turn the volume down so we don't get a feedback loop there. I also got involved with consumer virtual reality when it was just beginning to take off. So around that time, I wrote the VR controller for a 3D library called Q.js. Provided an easy, generic way for web-based VR apps to support a bunch of different hand controllers, because you don't want to worry about supporting, like a Gear VR controller and Daydream controller. You want to worry about your game, right? Or whatever experience you're making. So this made it a lot easier to focus on the fun parts, and I took care of the hard bits for you. Over at the Google Data Arts team, we used my VR controller library to power this VR music video for the band LCD Sound System. And I'm going to talk a little more about that in a bit. you could dance along to the song in VR, and a recording of your dance would then become part of the video itself. So each one of these, cone people with the little baton hands is someone who danced to the song and had their dance recorded and then incorporated into this video. And yeah, you can see some people are very enthusiastic about this. So I also released Space Rocks, which was just a personal project and not affiliated with Google or really awesome bands or anything. This was my personal tribute to Atari's 1979 classic Asteroids, but in VR, of course. And I took my VR controller library and I added something I called multi-channel haptic feedback, which made it super easy to add complex haptic commands to your VR apps. So like if you need to feel kickback in the controller from firing your laser, but there's also like the hum of the engine revving up and down, that's really complicated. This multi-channel haptic feedback thing made it very easy to just describe in code succinctly what you want, and it takes care of the rest. So that was a lot of fun, of course. A few years later, Oculus upped the game by adding hand tracking support for web-based virtual reality. And I immediately wrote this handy JS library. You'll notice JS is a big theme. I love browser-based stuff and JavaScript, so you'll see that pop up a lot. So what this does is it makes recording and then recognizing hand poses on the fly really quick and easy to do. So instead of just pinch gestures to like select things, you can recognize tons of shapes, including the whole ASL finger spelling alphabet. Finger guns is the most fun. You ever, as a child, just pretend you could shoot lasers out of your fingers? That may sound childish, but come on, it's fun. I made it possible, so there you go.
You made it possible for us to imagine that.
Mm-hmm. That was a bit of a stretch. Yeah, that was a bit of. I didn't think anyone would call me on it, but I'm glad you're keeping me honest.
Well, I work on lasers. If you figured out how you do it with your fingers, yeah. I'd really like to know how.
So would I. That would be fun. So I've made a lot of work outside VR too. I started coding when I was quite young, but I'm educated as a graphic designer and artist. I didn't study computer science. I've worked, well, I guess you covered this. I've been a commissioned artist, lucky enough to have some work in different galleries and museums. I'm also a lifelong mediocre to terrible musician, so you'll see music pop up a lot in the stuff I do. And I even enjoy writing essays occasionally, despite having no license to do that. I think my friends who are actually gifted in that medium cringe when they read what I've written, but it's fun to write. It's fun to communicate with people. Speaking of which, and cringeworthy things, I started to become aware of design as a kid. I had started this low budget magazine as a teenager, or a zine, as the kids say. Basically as a ruse, as a hack. This was a way that I could meet and interview some of my favorite bands, and their record labels would like send me the music for free, pre-digital streaming. But that was pretty amazing. I don't know if you've ever tried to meet a band after a show. They purposely make it impossible. But if you get in touch with the publicist and say, well, I don't even really want to meet the band. I just, I have this assignment. I have to interview them. They're like, oh, well, right this way. And you get to meet everyone. And they will send you all of the ephemera and music and albums and things. And it's great. So I'd do that. And then I'd also interview musicians about the heavy political topics of the day. So that was a way to combine an interest in music and politics. And all of this meant that this graphic design is terrible. This is teenage graphic design. But what it exposed me to is I had to start thinking about visual hierarchy and typography, and the interplay of text and image. So even though this was terrible, it planted good seeds that I would later follow all the way here to Yale. So I received my MFA in graphic design just a few blocks over. Somehow I squeaked through. And after Yale, I moved to Europe for a while. I became an artist in residence at ZKM, or ZKM, as it's said. That's the Center for Art and Media Technology in Karlsruhe, Germany, in southern Germany. Beautiful, Beautiful place. Folks there might say that it's very boring. I thought it was quiet and lovely and a really good place to get work done. But eventually I moved back to the US and joined Google's Creative Lab in New York, which is sort of a subversive marketing department now that I think about it. And later I jumped to Google's data arts team to do some more music video work. So I've also spent some time at various other large tech companies doing whatever large tech companies do. And I'm currently head of consumer augmented reality at Unity, and everyone knows Unity, right? Have you heard it? Yeah. Yeah. So our game engine is all about making real-time 3D rendering for the masses. 70% of the world's games are made with Unity. And we're not just 70% of, 70% of mobile. Definitely make sure I get that right. We're not just 70% of mobile games, we're 50% of all games. So if you play games, you've played something made with Unity. So like I said, that's
Meaning you're the drive
The
software,
overview.
so I'm the person that has no idea what Unity is.
Unity is a way to make game development much easier and distribution. So you could make your game once in the Unity editor, and then you can say, I want to launch it for Windows, I want to launch it for Mac, I want to put it on VR headsets and whatnot. And while there's still pain points in the development of complicated software, Unity helps grease those wheels and make it much easier to do.
Does it have its own programming language, or it just uses some existing language?
Unity is primarily C# focused. So if you're familiar with C# or Java, C, C++, any of those things will translate nicely into Unity stuff. Happy to talk more about Unity too after all this, if you want to talk about that. But I want to show you 4 things that I think are kind of different from each other, and I'll give you a sense of how I think about this stuff. So the first one is a project called Racer. This came out of Google Creative Lab. Google's Chrome team was enjoying this big market share for desktop, so Google was very happy. However, Chrome on mobile was not so popular. I think just people weren't really aware of it. And so the Google Chrome team asked us to make an ad campaign. Typical marketing ask, like let's do maybe some TV spots, posters in the subway, stuff like that. And we said no. We said we have a better idea. We were starting to obsess over racing games and slot car racing games in particular. And I started brainstorming just random ideas about tracks made of software that could change on the fly, that were modular. And I also created some quirky crash demos that were inspired by early vector games like Asteroids and Tempest and whatnot. And we also had this idea about racing across screens. So you literally needed to have multiple phones or tablets or what have you next to each other. It was taking this idea of social gaming and pushing you physically together. This was obviously pre-pandemic. It'd be a little strange to push that today. And so this was the final result. We said, no posters in the subway, no TV spots. Let's make this game that shows off how powerful Chrome for mobile really is. So you don't just say, we can show you, and we can make it fun, so you actually want to be shown. Our racing game needed a soundtrack. And we actually convinced this guy, Giorgio Moroder, to score the soundtrack. And he wrote individual tracks for each phone. So one phone would be playing the percussion, one would have like the lead melody and so on. And if you're not familiar with Giorgio, he's an electronic disco legend. And he's collaborated with Daft Punk more recently. And yeah, he's a legend in the community. I still can't believe we got him to do this. So those were all the ingredients for this game. And here's what that experience looked like. So I think you can see how you need to hug the track. I should have maybe explained beforehand, if you're not familiar with slot cars, the whole idea is that you don't get to steer. You just have one big dumb gas pedal, and you need to go as fast as you possibly can on the straightaways, and then let up when you hit the curves. Otherwise, you spin off the track. And so we replicated that behavior here, where your beautiful flagship multi-touch device was just used as one big dumb button, which we thought there was some humor in that. So Sundar Pichai, who's now Google CEO, he unveiled Racer at Google I/O that year, and the tech press loved it. And so that's kind of what we were aiming for, was this recognition in the tech community, and then also in the broader community, people just playing the game for fun. But we also struck a chord with the music press as well, which we didn't really expect, and that was awesome. People were really getting on to the fact that Giorgio Moroder had, aside from Daft Punk, he had come out of retirement for us to do this. So off the record, we made a limited vinyl run pressing of the soundtrack, and Giorgio even signed our copies, so that was pretty great. This was a fun project on its own, but as a nice bonus, we were awarded the Canline Gold for creativity and innovation on mobile devices. You probably don't know what that is because it's a silly industry award for like marketing, but it just means people thought it was cool. So that made us happy too. So sadly, Racer is no longer live. I think some of the website still exists, but it'll say something like your network is too slow, which is just a fake error code for, we were only going to support this for about 12 months anyway. It's a marketing campaign, and now it's off the radar. Otherwise, I'd race you all. We could have a competition up here. All right. Next project, Autocompose. This is a much less visual project, and I think it demonstrates a predilection for combining interests in product design, marketing, and also cutting edge research. Just kind of blending all of these interests together. So back in 2013, I had more or less accidentally followed ex-Google star Marissa Mayer to Yahoo. And the narrative there was that Marissa would rescue this once great company that at this point was falling apart. And Yahoo Mail in particular was in need of rescuing. So we got this official ask from the Yahoo Mail team, from the product team. They wanted a Valentine's themed marketing campaign. And I guess that just came to mind because it was late January and they're like, what's a reason to promote something? Regardless of the reasoning, they gave us this ask near the end of January, which meant we had about 3 weeks until Valentine's Day. And also because we needed to put all these plans in motion and into production ahead of Valentine's Day, we really had about 2 weeks. So it's kind of a nightmare scenario when someone comes to you and says, 2 weeks from now, we need to have something that changes the narrative around Yahoo Mail from everyone being upset to people saying, oh, isn't that a nice product? So I had an idea for this. It's an idea that I'd played with a few years prior during the height of the iSomething craze. So think iMac, iTunes, iLife, and the crown jewel at the time, the iPod.
Yes.
iPhone and iPad were still super secret skunk works projects that no one knew about. And that idea was, I quit. I apologize for the language. This was a resignation letter generator. So your job, your relationship, your friends get out of anything instantly with I quit. This is a real, that's useful, right? This was a real functioning website that I launched. You put in the email address of who you want to quit, and it would do the rest. It would generate a random formal letter of resignation and send it to them. Yes, very, very useful. The faux testimonials I had on the website were absurd. I used to do corporate advertising until I realized having a soul is nice. I fired up I quit, bam, now I can starve with pride. It's just it's kind of ridiculous faux testimonials. Here's an actual sample email that it generated automatically on the fly. This email serves as my formal letter of resignation, effective immediately. It's not my intention to injure feelings with this letter, but to merely illuminate a path toward a more functional environment for myself. And it goes, it's ridiculous, right? But
Did you write all this?
The way that I made this original version is I had a list of opening lines, tons of middling lines, and then a few choice closers, and it would randomly assemble those on the fly.
So they are kind of randomly.
And I'm glad you asked about that, because that's the seeds of what we're about to talk about. So that's when it hit me, this Valentine's Day campaign. Writing love letters is hard. Right? Dear Jane, you are so neat. It's a pain, right? So I quickly, taking that sort of humor, I coded this demo that constructed love letters automatically right in the Yahoo Mail compose window. And if you didn't like the result, you could just edit it yourself or click the Autocompose button again for a new composition. So you can see it just cycling through, you click, and then it gives you these things. I also created this interface for our copywriters so they could craft their lines and test them. This is like a showcase for a good copywriter, right? Because it's all about the language that goes in there. It's really all about the text. And I feel like you rarely get to do that in a tech marketing medium, but here it is. So I wrote this pseudo programming language. So literally they could just write opener, have a whole list of openers, and then there's like Mad Lib style replacements and things that it could do as well. And it would automatically take what you've done in here and use it as the contents for what was being generated. In this way, they could test if their lines really work together. Sometimes a brilliant line of text seems like it could flow into another, and then you see them juxtaposed and the language doesn't feel right. So this was a way that they could gut check a bunch of compositions. And also it was really important to me that the number of permutations possible exceeded the number of daily active users, so that in theory, every single person using Yahoo Mail could generate a love letter, and every one of them would be unique. So it was a lot. And we launched it in time for Valentine's Day, and it was a success. We were able to change the conversation around Yahoo Mail from hate at the time to something a bit more amused. People were at least smiling and sharing this. So yeah, the sentiment was positive for a while. So because Autocompose was a hit, we immediately started looking for ways to take it even further. And you had asked about how it was constructed, and it was just lines of text, and they were randomly assembled together. That was good for a 2-week project, but to really go further, we needed actual machine learning.
Right.
And thankfully, right around that time, Yahoo had purchased this startup called Sumly. And what it did was automatically summarize long news articles into very short snippets. So I was able to take these ideas together and sketch that out into a patent for using existing emails as training data for constructing new email drafts. So you have an email corpus of all of your missives to friends, your mom, or whatever, and the way that you interact with different people will be different. If you're emailing a professor, I would imagine you don't speak in the same way that you might speak with some of your friends. There may be a bit of more formality or what have you, or maybe not. I don't know your professors individually. But the point was that we could use machine learning to look at those correspondences and then predict or imagine what another correspondence would be between you and that recipient. So let's say you have the flu and you need to find a way to apologize to your buddies for missing an important birthday. If you're really feeling sick, do you want to write that email or just let the computer write it for you and apologize? I'm skeptical about whether we want any of this stuff, but it was fun to work on.
Well, you're certainly making everybody lazier.
A few years later, Google did the same thing. And instead of Autocompose, they called it Smart Reply. So I'm not saying I invented Smart Reply, but maybe it was just in the air at the time. I like to float that and pretend I'm more important than I am. But, anyway, I wrote about all of this in an essay called The Charm Offensive. So if you're curious to know more, semi-humorous essay about how this came to be. Okay, sorry, second to last one here, called Dance Tonight. So virtual reality has become a big part of my life for the past few years. And the first VR system that I ever tried was a Vive dev kit. And once I tried it, I knew immediately I wanted to make stuff for VR. But I'm a web guy, so I had to find other people who were building web-based VR tools. And this was in the very early days of this stuff. And I started making little demos like this, where you'd be in this weird rippling environment of this kind of dream sand substance that would swirl together to make objects. And I don't know, I thought it was very artistic at the time. And now I'm like, well, it's a decent tech demo, I guess. But these were the early days. I also built some early co-presence demos. And again, all this stuff was running in the browser. One day I got about 80 folks in Google Creative Lab to join me in this little VR universe. So everyone was these sort of peg people, and they could look around, and everyone would have this randomly generated name that was a random color and a random animal. And you could run around like little Mario characters and teleport between worlds, but that was about it. That was about the extent of the interaction. But for late 2015, not bad. That was a technical feat. I created this day and night web app for my kids. Their grandparents live in Europe, and I wanted to give them a better understanding of how time zones work. So here, they can float in space. You put the headset on, and you're in outer space above this rotating Earth. And the city lights come on as night falls, and you can get a sense of how it is the middle of the day in one spot, in the middle of the night in another, in a very visual, visceral sense. So this universe is movable and scalable. I was making something for my kids, who are obviously a little shorter than I am. So the whole idea was that you could grab the world as if you were going to do pinch and zoom like on your phone, and you could expand the universe or contract it and rotate it and put it wherever was comfortable. So you could have the Earth kind of about this size, just floating here, and that's fun. Or you could make it huge, and you could be kind of floating right next to the curvature of the Earth and watching as it shifts between day and night. This was another thing that I was working on that does not seem to flow so smoothly when we're trying to mirror screens here. But this was a giant data visualization of flight patterns. And I ported this to VR, and you could do the same thing. You could expand it, and you could actually sit inside the Earth and look out and see, well, here, if we're not over the ocean, there's a bit more to look at. You could actually see all of this stuff swirling around you, which was viscerally a lot of fun. And so I was working on this VR stuff while I was at Creative Lab, and then I moved over to the data arts team, which is another team within Google. And this was the first thing that I put into motion over there. I won't dwell too much on it since I mentioned it earlier, but it was just a way to make working with VR controllers easier. And but I'm happy to dwell again on Asteroids because I love that game. So here it is translated into VR, or if we go back for a moment, the original Asteroids is a black and white vector game. And that's because of the hardware. It was built to run on a Vectrex screen. So speaking of lasers, well, I guess, would you consider that a real laser? Or yeah, okay, yeah. I like to think of it as a laser, but I realize that's just because it sounds cooler, but it's not a real, yeah. Anyway, photon gun, electron gun, that's a more.
Yeah, electron gun is different,
yeah. Yeah. So that's why it looks this way. And I wanted to translate it to VR. And at first I was tempted to make something that looked like this, but I realized conceptually I should probably be doing what the hardware wants, and in a way that's truer to the original game. And so that's why it ends up being these flat surfaces with shading to indicate their depth and where they are in space. So with all of those little VR pieces in my palette, and now with the data arts team, that's when I made, and when I say I mean we, the team, made Dance Tonight. And it's an ever-changing dance collaboration between LCD Sound System and their fans in virtual reality. So when you load it up, you get this little tutorial. This ball represents the camera. It enters the room and the room lights up, and that means it's time to dance. And each room represents about 8 seconds of music. That's the amount of time it takes for the phrasing in the music to turn around. So you record your dance, and then you can actually record multiple dances. So it could just be you doing this, but you could build up, I think, yeah, 20 copies of yourself if you want to. So you can start to make more complex movements and things, even if you're just on your lonesome. So here's what it looks like from the inside, which is a little chaotic because this is someone actually dancing. And let's see if I can do this with sound without feedback. You can see the ball is a ball is a ball. That's entered. Okay, I will turn down the sound so I don't get that feedback. So this way I can talk through something like each one of these people is selectable. So let's say I'll grab one of these folks over here. And when I click on them, this is their point of view camera. So you can relive that dance experience. Which may make you sick since it's this added motion. You can also, let's see where the ball is. You can also grab the ball. And this is a little more of a steady cam experience. So you are now the ball floating through here. And if you do this in a VR headset, you don't just have the straight ahead view, you can just look around and it's like you're on this slow moving carriage and you can see what's happening everywhere else. Let's see if I can jump on the timeline here. It goes on to this other part of the universe where you're no longer constrained to these rooms. And you can see all these other folks dancing and reacting to the music. And I think you get the general idea for this video. So we launched it at Google I/O again, and we had this big party. You can see all of this ridiculous, we actually built rooms, physical rooms that correspond to those virtual rooms. So you have this trippy experience where you step into the physical room, put on the headset, you're in the virtual room. And also people are in a ball pit, which seems like it should not be real, but that was physical. Kids as adults, you could write books about that. And here's, yeah, just a bit more of a overview. This, I'm not making fun of this guy by having him here. He's actually a very well-known, well-respected VR journalist, and I'm so excited that
Florian. That was
No. I'll take it. Can I do it in the room?
So that was a lot of fun and a fun way to launch the project as well. All right, so this is my fourth and final project to show. Since this is for YQI, I should probably talk about something quantum related maybe. But before I do, I want to make something clear first. Let's say that this circle represents quantum physics. This is all the knowledge about how the universe actually conducts itself, right? Photons, locality, thermodynamics, packets of light, whatever you want to talk about. And over here is quantum computing. And this is pure math and logic. And you don't need to know so much about electrons or superconducting to just write computer programs. And of course, you have that intersection, the actual quantum hardware, quantum computers themselves. But this is the realm that I'm more comfortable speaking about because I am not a physicist, I'm not an engineer. And if we're being totally honest, my personal knowledge scape looks a little more like this, random puddles of knowledge. Even this is generous, by the way, rather than a vast ocean of knowledge that I think many of you folks have. But also this, because we humans are beautifully messy, nonsensical creatures. So with this disclaimer in mind, I can talk about some of my quantum projects. So I'm the creator and maintainer of Quantum JavaScript, or Q.js for short. And I'm the founder of Open Quantum Club. So what is this stuff exactly? Well, we can go deep on Q.js for a second. It's actually a few things at once. It's this website and the corresponding source code repository. It's this drag and drop circuit composer interface in particular. It's a quantum circuit simulator because this is just software, right? It's not actual quantum hardware. It's the entire code library and its corresponding API. It's some concept primers that are there to help get folks like me up to speed on quantum computing quickly. Folks with no real physics background or quantum background, just casual coders with some rusty high school math. It turns out that's all you need to start making some fun mistakes, and then you can learn more as you go. And it's the documentation too for the Q.js API, because what good is a library if you don't know how to use it? And when you put all of this together, there's a small but growing community of enthusiastic folks who have also fallen in love with this ridiculous idea of fusing quantum and web browsers. Because JavaScript wasn't chaotic enough on its own, right? Do we have any JavaScript coders here? Know what I'm talking about? No? Really nerdy jokes. I'm so sorry. So for this community, I'm starting something called OQC, the Open Quantum Club. And this is a project, I'm just spinning it up right now through a website that will feature profiles and interviews with folks in the quantum community. So the special focus here will be on the humanity behind the math, since that's what I'm better at, obviously. So who are the personalities? What are the collective hopes and dreams and that sort of thing? So stay tuned for more about that as we head towards 2023. But let's talk about the, oh yeah.
Is it more like an interview project?
Yes, yeah, and I've conducted my first interview and forgot how difficult transcribing a long interview can be, so I need to finish that, and the website is partially finished, so it's in progress but not ready to launch, but yeah, mostly interview based. So this is the Q.js website, which is really the hub for the whole Q.js experience. There are quantum tutorials, the API documentation, all the things I just mentioned. I'm going to play a quick demo video for you that I made to show off some of the features. Okay, all right, Quantum JavaScript. It starts off with this interactive circuit building interface that runs right in your web browser. And I'll explain what these things are in a moment, but I'll just show you how it operates first. We can select everything and throw it away and start over. We also have an undo button here, which is great, and also a lock button, so we can lock our circuit and can't mess it up, can't select things, can't throw stuff away, which is even more helpful on a mobile interface where there is no hover state and selection. You're tapping, perhaps you're tapping to scroll, perhaps you're tapping without meaning to, and you definitely don't want to mess up a circuit that you've carefully composed. But in this case, we can throw down an identity gate and maybe a poly-X gate and select them and combine them together to make a controlled gate here. And what we've just created here is a bell state. And even if you don't understand any of this stuff, you can see the live probability results being updated in real time as we change things. So it's really cool that you can drag and drop stuff together, but you can also code things, code the circuits with JavaScript. And what's even more than that is you can combine the two. So if we open up our JavaScript console here, let me clear it out. It says that this circuit is accessible in our console. And so let's give that a shot. Let's see, we get a circuit back. Here, let's make this a little larger. Let's see what that circuit looks like. We can get a diagram of it. It's not very interesting when we have a blank circuit. But here, we can quickly build that bell state again. And you can see as I'm editing the circuit, we're getting real output just like that. And here, let me scroll up. So we can actually see that this ASCII diagram
looks very similar to what we have right here, doesn't it? And so that is pretty cool. And what's even cooler is we can start to do things like, let's say we want to add another one of those H gates, right? That's a Hadamard gate, and we'll talk about that in a second. Let's add it to moment 3 on wire 3, which should put it right there. Let's see if we can do that. Oh, and there it is. So we can actually jump back and forth between code and the drag and drop interface. So it's not about dumbing something down, not at all. With Q.js, you have access to this quantum circuit both through code and the drag and drop interface, and you can fluidly switch back and forth to whatever has least cognitive overhead in that moment. Let's say I need to get rid of everything here in moment 2. I could certainly code that, or I could just select it and throw it away, right? So I just want to emphasize that designing a user interface and offering pictures to look at and click on is never about dumbing something down. It's about making tasks easier and more efficient for us human beings who require that.
So Q.js definitely sits on the software side, but I happened to work at Amazon for a while, and Amazon just so happened to be working on a quantum service called Amazon Bracket. You can access Bracket through a prepared Jupyter notebook, if you know what that means, which is similar to other quantum services, quantum cloud services. So anyway, here's a little demo video that I made just a few months before Bracket launched publicly using the Q.js interface to drive it.
So here I have a Jupyter notebook with Amazon Bracket loaded, which means that I can use Python code. Bracket is a Python library, and I can use that to build quantum circuits that I can then run on a simulator in the cloud, or I can run on quantum hardware, because Amazon has partnered with different quantum hardware vendors, and so we can do that. We can offer that to our customers, and that's pretty exciting. But what's also exciting is this. With just a few lines of HTML, really 2 lines of HTML, I can inject Q.js into this Jupyter notebook. It's now injected, and now I can inject my quantum circuit composer. And this composer, which should look awfully familiar, is writing Bracket code. So this is actually Bracket Python code, which right now is set to run on the simulator in the cloud so that we can get quicker results. But if you wanted to, you could switch what device we're running on, and you could actually run this on quantum hardware and get true quantum results. So check this out. Down here you can see where it says our Q.js circuit equals a new circuit, and it has a placeholder identity gate. This is Bracket code, and we're about to watch it change as I start to compose stuff. Look at that. Look how it put a Hadamard gate and created a C0 gate. And we can take that and we can run that. What this is a coin flip circuit. And we're waiting for the output to come back from the cloud. So Hadamard puts the qubit into a state of superposition, and then this distributes that superposition to the qubit on the second register here. And so our 2 possible outcomes are 0, 0, and 1, 1. And you can see we've gotten a result back from the simulator. It's run that simulation 100 times, which is a customizable number. And it's come back roughly even. 54 times it came out 0, 0, and 46 times it came out 1, 1. So here's the deal. We can drag and drop and build circuits as we please using the Q.js drag and drop interface. We can even edit that thing and get real-time reports in the JavaScript console still. and it is building Amazon bracket code, which we can run on a simulator or on actual quantum hardware. So that is pretty cool.
So that's it for quantum JavaScript.
Question?
Yeah.
So for the Amazon bracket, is it a hardware quantum computer or it's also a simulator?
Both. So they have their own, because they have a huge cloud infrastructure, they have a pretty efficient simulator that runs in the cloud. But then they partner with like Rigetti and, oh gosh, now the caffeine's wearing off. But they have a few different hardware partners. And so you can actually select which system you want to use. All right, maybe it's time to wrap this up. And that's me and the sorts of things that I make. I'm happy to take more questions, or if you're curious about other work, I'm happy to show more things. But we can open it up a bit.
Why do you focus on the web-based applications rather than the other?
Well, I guess there are two reasons that I focus on web-based stuff. One is that's where I learned to code a lot of things, because you have access to the source code, even if it's not technically open source. Everything that's happening on the front end is there. You can just view source in the browser and start to pull it apart.
You can?
Yes, yeah. Things are a little more locked down these days, but there's sort of the Wild West days of the late 90s and early 2000s where you could take apart websites to a much greater degree. So that's how I learned to do a lot of stuff. The other reason is it's so immediately shareable, and I think that's pretty highly valued. And everyone has a web browser on their computer, so you can also be sure that you can run things. And yeah, it's just a huge, I want to say market share, and that's the wrong word for it. It's a huge distribution channel.
Is there any limitation? Can you do everything you want with the browser? Or do you have sometimes like what's
there are definitely limitations, but a lot of them are melting away every day. So for instance, right now I'm playing with a hardware accelerated simulation algorithm for Q.js, because you have through the web GPU API, you can get right onto the graphics card hardware and use the hardware acceleration for that. And in this case, instead of making fancy graphics, I'm just multiplying the large matrices of quantum states. Yeah.
Oh, sorry.
How did you get interested in quantum computing?
Oh, well, I should probably have a real conceptual answer for this, but just for a long time, I thought quantum physics and quantum mechanics sounded really cool. I was like, wow, that's neat. And I kept trying to wrap my head around it, and I couldn't. But, I keep watching like the pop science explanations of what quantum is, which, once you start learning anything about it, you're like, that's stupid. But then I came across a video by this guy, Andrew Helwer, I think is his name, from Microsoft. And he gave an internal Microsoft lecture that they published called Quantum Computing for Computer Scientists, which is him summarizing his favorite book on the subject. And suddenly the way he was describing it, just as coding, made a lot of sense. And I thought, oh my God, I bet I could just write that. And I bet I could write it for the browser and then start sharing it with folks. And that was my first actual understanding of how some quantum stuff works. I would say I still don't understand any of it, but I could build a functioning simulator. So. Any other questions?
Yeah, such a kind of follow-up. So why would someone use a web-based application compared to a desktop-based application?
That's a good question, but I'm not sure. There must be desktop applications, but when I think about Qiskit or just the other things that I've seen that are basically running in Jupyter notebooks, those things are all web-based. Even if they're presenting themselves as a native application, under the hood, they're basically running little web servers and the like. And it seems like that's okay, because what you really want to do is you just want to have an understandable interface to take your thoughts and put them in a way the computer can understand. And then you're going to push that to real quantum hardware anyway. So the medium in between doesn't really matter as much. And even with the simulation stuff, either you're simulating on the cloud, so it's just sending the instructions to many computers to come back, or you're trying to do hardware acceleration on your own local machine. And you can do all of that through a browser. So you don't necessarily need a native app.
Okay, thank you very much for coming, and thank you for all your questions. Let's thank Stewart Smith once more time, and then we'll see you, all of us, for the public event in the fall. Thank you very much.